So, my name is Alexandra da Silva. I work at the University of Minho in Portugal, and I want to share our first experience with the PocketQube. We launched as well with Hype and the other ones in January, our PocketQube. I won't be talking much about the technical stuff regarding the PocketQube, but instead I will talk about the impact of the PocketQube for us, and I put here a bold subtitle about the possibility of the responsibility of that the PocketQube might have, especially in Portugal, in terms of the education of the future generation of the aerospace engineers and others. So for sure, because many of you don't recall Portugal as a space nation. Yeah, we don't have much track record on that. So when we started working with the Prometheus one, our goal was more on educational side of the PocketQube. What we wanted was a kind of a satellite platform that we could use on our classrooms, not as an extracurricular activity, but as an intracurricular activity. So we wanted a platform that our faculty could use for teaching engineering, energy power systems, embedded systems, control, instrumentation, sensors, even space law for launching satellites. And we wanted our PocketQube to be that case study for the students. Okay, so it was developed with that in mind, so that we could use for aerospace engineering programs, industrial electronics, telecommunications, physics engineers, etc., etc. And to make it as most real as possible, we wanted to share a full experience. So the design was for learn by doing. So we decided to build our PocketQube so that we could later share all the process, all the pipeline from the moment that you start designing until the moment that you start operating the satellite with our students and do like a real case studies in the classroom. So we have one PocketQube right now in orbit. We have a kind of a few kits available in our classrooms, and there is no difference between what is in orbit, what is in the classroom. It's all the same, only the frame is done in a different materials. We didn't need to use a space-grade material for the frame for the classroom, but everything else is the same. It's the same components, it's the same ICs, and everything is the same. So if it worked in the classroom, it worked in space. That's the idea. So what is the Prometheus PocketQube? It's a small satellite, just waiting for it to open. And basically, what does have that is, I think I will highlight what we think is the most interesting features for pedagogical purposes. So it has an OBC based on a microcontroller on an M4 Cortex that has a circuit Python layer on top and allows students to program in Python. Usually students like this, so that's why we decided to go to Python. It's not the best language for space, but well, for a classroom it's quite interesting. It does have a camera with their own MCU for targeting image classification. This was a kind of a trial. We wanted to see if it worked or not. It does have as a radio that communicates in amateur band radio and the amateur frequency, because we wanted students to be able to listen to our satellite while they are at home. We wanted to ask other amateur radio users to listen to our satellite around the world. So we decided to go with this frequency. By the way, not sure why, but this frequency was the same frequency that our friends from Hype, the previous PocketQube, was also offered. So we didn't decide for this frequency. IARU, the union that regards the amateur frequency coordination, gave the same frequency to both of the satellites, and to make it worse, both of the satellites were next to each other on the deployer. So over a couple of weeks we were like, is this data from ours? I was texting Philip from the other team, he's not here today, but saying, is this yours? Because I was like, it doesn't make sense for us, but we are trying to figure out if it is like a package loss or package error. Crazy weeks, believe me. So, but let me go back to the initial proposal that I was sharing with you. So Portugal as a space nation. From Portugal launched its first satellite 30 years ago, a little bit more than 30 years ago. It didn't launch any more satellites until the last year. So we basically, during 30 years, we didn't launch anything into space. We didn't have any track record in space. We didn't even a space law that we have just now launched in a couple of months ago. But since 2024, we start launching satellites. Portugal puts, until January of this month, of this year, put in a 10 months, more or less, puts 4 satellites in orbit. And while they are very interesting because they are all different, one is MH1, was the first one to return to space. It's from SEA, it's an R&D company, it's a kind of R&D interface system. We have IST-SAT-1 for those that were paying attention to the FlyOrSat program this morning. This one went on the maiden flight for Ariane 6 in July, and then in January, Prometheus 1 and POSAT-2 went into orbit. But let me put this in a different kind of scheme. In a scheme of pipeline in terms of capacity for Portugal. What does it mean? It means that for now we already covered the entire capacity pipeline. From education, that's where we are, from science and research, for R&D until a commercial satellite. POSAT-2 was the first Portuguese commercial satellite being put in launch. So at this moment we can more or less, because Portugal is quite a small country, we know all each other. We are 4 teams that have experience in launching and putting satellites in orbit. And this is very critical for us because, as on the slide before, let me see if the pointer works. We have currently, if you are aware of it, the plan to launch in the next months and years 16 new satellites, commercial satellites, between Portugal and Spain. We are putting what we call the Atlantic constellation in orbit, which is a set of more than 10, almost 20 satellites that will be monitoring the Atlantic Ocean in terms of the water, in terms of maritime navigations as well. So that's why Prometheus was critical for us. We wanted to train the next generation of students so that when they are outside of the university and they are working on these companies that are launching these satellites, they have experience, and we wanted for them to have the real experience of going through the process. So, just a quick remark. So, Prometheus, we decided to make these kind of YouTube videos for our students to learn how to build the satellite, because as more interactive as possible for them. We share all the experience of qualifying the satellite for flight. By the way, it failed the first time. We did a mistake. We didn't know. We just figured out when it failed the first shaking process. Then we need to redo the shaking. It was very, very stressful for us. We were just a couple of weeks ago of coming here to integrate the satellite in Alba. So it was very stressful for us. We did a mistake. We did integration, and we play with our students when they are building and programming the satellite. That's what we want to share with the students, all the process, from the building to the launching, to the operation, even to the licensing requests. Many times we don't focus on that. We only focus on the hardware, but the licensing, the paperwork that we need to put and need to get is quite interesting to find, especially in Portugal, where we were alongside with the law that was coming out. So we were the 3rd satellite to get license in Portugal for launching and for operation, the 3rd one. So we were running last year kind of a space race, our own space race in there. By the way, so we didn't do this alone. In order to speed up the process, we did this in terms of collaboration. We did this with the IST, which is a technical university in Lisbon, in Portugal, that had the prior experience with the IST-SAT-1, the one that went on the maiden flight for Ariane 6 on FlyOrSat. So they were a couple months ahead of us, so they were very critical for us to understand the licensing process, because they were doing a few months before us. And we also did with this Carnegie Mellon University that designed the initial platform. It's called PyCubed-mini. And we did it together. And this was the way for us to speed up the entire process and to get to space and now be able and confident of building our own satellites. Current status. So yeah, that was the day, the big day, January 14. We watched it. This is at around 7 p.m. Tom was there for the big party that we hosted at our university. Then 1 hour and afterwards, the OTV was deployed. So Ian, Eminent, Emmanuel from the orbit was deployed. We needed to wait a few more days, around 1 week and a half, for January the 23rd, for the full deployment of Prometheus 1. And what happened is that we believe that 5 minutes afterwards of being deployed freely, this was he was expected to do. So he was expected to do a GSM check, he was expected to do an antenna deployment, and await a contact from Earth. We didn't start by broadcasting a beacon. Not sure if it was the best decision or not, but it was still silent and waiting for our contact. But we got the contact on that same day, so this was, so in terms of hours, so we did the deployment around 12 and a half, more or less, and by that day at 9, we were able to do the first contact with the satellite. We were able to request the first beacon and start the communication with the satellite, and we also were able to request the image. We were a little bit bold in terms of the decision in terms of operation, what to do on the first operation. We can discuss and argue if it was the best decision or not, but we decided to do this, and what we see was this data. So this is what was coming out from the telemetry, and at first sight we were trying to decode this, but as you know, we just have like a 10-minute window, so we needed to take some decisions, and we didn't look very well at this data, and we decided to request the image. What happened is that our satellite had been in stow for quite some time between the time that we delivered. It still had a fully charged battery around September, but then we just launched it in January, so there was a period of 3-4 months that we was draining the battery. And we basically, when we requested the image, we basically forced the satellite to enter into safe mode. And the issue of going to safe mode was that it's going to safe mode to be able to charge up to be fully operational again. But it was with this tumbling rate. It was around, let me see here, the gyro -6 radians per second, almost -7 on that axis, which is around more than 1 rotation per second in one axis, and that's too much for us. It's too much for us because our system, our satellite has a magnet torus on the outer sides of the satellite, on the outer panels. But to activate the magnet torus, I need charge. I need the batteries to be charged. But to charge the batteries, I cannot have the satellite being in such rotation because it doesn't have time enough for the panels and the system, the APS systems to work because there is a latency, a lag on the system. So we are now currently waiting for a kind of a natural detumbling, or at least slowing down a bit so that we can charge it a little bit up and start doing the detumbling with our magnet torus. And that's the final result. Still for us, it's quite a successful mission. We are very happy with it, how it went. We learned a lot, and we are currently basically sharing this with our students inside of a classroom. They are doing the building, they are doing the mission control, they even are doing like this kind of a submission of licensing requests, and I'm being like a kind of space activities regulator and revising their licenses requests. So they are learning this for sure to have the full experience and be able to work on the satellites that we are producing now in Portugal. And yeah, to finalize, this is the team. Myself, Pedro was a student, then Zachary Manchester from Carnegie Mellon University, and Rodrigo Ventura and Rui Rocha from Portugal. This program was funded by Carnegie Mellon Portugal program by our National Science Foundation. Thank you so much.